So one of the derivations of the ideal gas law is the calculation of density. And unlike solids and liquids, the density of a gas depends on the pressure that the gas is at, its molar mass, and its temperature. And here are two equations for the density of gas that you will be required to use. Here's the first one. Density is equal to molar mass, this capital M with a subscript M is molar mass, times the pressure divided by the gas constant times temperature. That allows you to calculate the density. And the units for density, let me put this over here, the units for density are going to be grams per liter because gases are mostly empty space, so the volume that we're looking at has to be a large volume. The molar mass of the gas can be calculated if you know its density at a given temperature and pressure. And R is in both of these equations, and if we remember the units of R, atmosphere times liter divided by mole times Kelvin, that lets us know that our pressure units must be in atmospheres and our temperature units must be in Kelvin. Okay, so let's go ahead and look at a problem. Calculate the density of a gas at 775 torr and 27 degrees Celsius if 0.25 moles weigh 9.988 grams. Okay, so the first thing that I do is I know that I have to calculate the density of a gas. So therefore, I go ahead and write out the equation that I know I'm going to need. The density of a gas is equal to its molar mass times its pressure divided by RT. And it'd be a good idea to have all these equations in one place, either of one page in your notebook or all on some 3x5 cards that you can readily access while you're doing your homework or your quiz. The next thing that I want to do is I want to go ahead and I want to label or write out what I'm given so I can figure out what my next step is going to be. So according to this problem, the density is what I'm solving for. So I'll put a question mark there. Now I'm not given a molar mass, so I'm going to go on to my pressure. My pressure, I'm given 775 torr. R we know is 0.0821 atmospheres liters per mole K, and then the temperature is given as 27 degrees Celsius. I'm also given that 9.988 grams is equal to 0.250 moles. Okay, so the first thing I notice is that my pressure units are not where they need to be. I need them to be in torr, and my temperature units are not where they need to be. I need those to be in Kelvin. So I'm going to do those conversions in a different color so it kind of sticks out. Let's look at my pressure first. I want to convert my torr to atmosphere by using the conversion factor. 1 atmosphere is equal to 760 torr. So my torrs cancel out, and my pressure is going to have units of atmosphere. And my calculator tells me it's 1.02, and that makes sense because 775 is just a little bit greater than 760. Down here at my temperature, I'm going to add 273 to my Celsius to get my Kelvin. And when I put that into my calculator, I get 300 Kelvin. So I'm going to put these in boxes because I'm going to need those. I want those to stick out. And now the one thing that I don't have is my molar mass. However, I am given that this mass is equal to this many moles. When we're given mass in moles, we can use this fact here that we know that the molar mass, let's see here, let me write it down here. Molar mass is going to be equal to mass divided by number of moles. So if I'm given 9.988 grams, and I know that that is equal to 2.50 moles, then if I divide the mass by the moles, I'll get the molar mass. And my calculator tells me 39.952 grams per mole. So my units are grams per mole, and this value makes sense. This is not a very large molar mass, but gases typically have smaller molar masses, and this is a reasonable value. Okay, so now I can go back up to my equation, and I have all of my values. Let me put my molar mass over here, 39.952 grams per mole. I have all the values that I calculated in a box here, and all I have to do now is plug into my equation. So my molar mass is 39.952 grams per mole, and I'm going to multiply that by my pressure, which is 1.02 atm. And then I'm going to divide that by R, which is 0.0821 atmosphere liter per mole K. Whoops, sorry. And then I'm going to multiply that by my temperature, which is 300 K. Now before I do my math, I always make sure my units cancel out. If my units don't cancel out, that's a clue that I've done something wrong and I need to go back before I waste my time plugging things into the calculator. My atmospheres cancel out, my Kelvin cancels out, my moles cancel out, and I'm just going to see if I can squeeze this in here. My units left are grams per liter, and that is exactly what I want for a density unit for my gas. And then I'm going to let my calculator do the work. I'm going to multiply these two values and then divide by the product of these two values. So my calculator tells me 1.65 grams per liter. And I know this page is a little bit messy, but I wanted to keep everything on the same page so you could see what I was doing and how I went from one place to the other. So that is our final answer. And the key to doing these type of problems is writing everything out, making sure your units cancel out, and just taking your time to do it stepwise.